Okay, welcome to the review of energetics. This is sort of the intro to the energetics unit, and we're just going to review a little bit about energy and some of the energetics type stuff that you did in Science 10, and then the next lecture we'll start to get into the energetics of chemical reactions. So hopefully you've pre-read this note already, and if you haven't, pause the video now and go through and pre-read this quick review note, and then come back, because I'm going to go through this pretty quickly, and a lot of it is things that you already know. So if you haven't already done so, pause the video now, pre-read this note through fully, and then come back. Okay. We already know from past experience that energy is the ability to do work, and we measure it in joules. And there's many different forms of energy. There's multiple forms of potential, and then there's kinetic energy. And the two energies that we are really going to be looking at, or the energies that we're going to be looking at, are going to be this chemical potential. That's the energy stored in the bonds of substances. Kinetic energy, in terms of the motion of particles, and by extension the temperature of particles. So when temperature changes, then we're changing the kinetic, or the motion, the speed at which the particles are moving. And then not so much radiant, but thermal energy. And in the case of heat, heat is the transfer of thermal energy from one object to another, or thermal energy in transit. And so we're going to be talking about heat and thermal energy is what our focus will be on. Well, we already know that different compounds store different amounts of energy, and so when we have a chemical reaction that changes one set of compounds into another set, the new set may store less energy than the original compounds did, and so therefore there's an overall release of energy from the reaction that's called exothermic. And if the new compounds store more energy than the old ones, then there's an overall absorption of energy, and that's called an endothermic reaction. And then there are a couple of major scientific laws that we have to certainly take a look at. The law of conservation of energy, which simply states that energy can't be created or destroyed, but only can be converted from one form to another. And then the second law of thermodynamics, that states that in any energy conversion, there's always some small amount of usable energy that's lost, usually as heat due to friction or other inefficiencies. And so no energy conversion is ever 100% efficient. As well, we have a couple of values that are referenceable. There is specific heat capacity. That's the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius, or 1 Kelvin. And the units for this are joules per gram degree Celsius, or joules per gram Kelvin, or we could go kilojoules per kilogram degree Celsius, or kilojoules per kilogram Kelvin. Regardless of the units we use here, the value, the numerical value, remains the same. So for example, water is 4.19 joules per gram degree Celsius, but it's also 4.19 kilojoules per kilogram degrees Celsius. So specific heat capacity is unique for each substance, and it accounts for the differences in their abilities to either gain or lose energy. And so therefore there are differences in the abilities to heat up or cool down rapidly. A slightly different value is called heat capacity. The heat capacity is the heat required to raise the temperature of a given mass of substance by 1 degree Celsius, and we can tabulate, or we can give you the heat capacity for an entire system. For example, if we're going to heat up a pop can with some water in it, well, we could calculate the heat capacity for that pop can with that amount of water, and it would be specific to the system as you have it set up. And so we typically do this if we want to make a question a little bit quicker to answer, a little less calculations involved. We will use heat capacity. So pay close attention to the wording, because if it's heat and the units, because if it's heat capacity, notice that the units no longer have a mass unit in here. It's joules per degree Celsius or kilojoules per degree Celsius, and there's no longer any mass. Heat capacity is calculated by taking the specific heat capacity for a substance and multiplying it by the mass of that substance. Well, in grade 10, you did heating, cooling, and phase change. And obviously, if something's heating up, it's absorbing energy to warm up, so to increase in temperature. It's also, if you're going from solid to liquid or liquid to gas, those are all energy absorption phase changes. And if you're cooling down, so if you're going from a gas to liquid, or from a liquid to a solid, or you're cooling and you're causing the temperature to decrease, those are all exothermic. You're losing energy. And in order to calculate those energies in the heating and the cooling phase, we use this formula in grade 10. Q, which is heat energy in joules or kilojoules, is equal to M, mass in grams or kilograms, times C, which is your specific heat capacity, times delta T, which is your temperature change in degrees Celsius or in Kelvin. So that's basically the review that of all of the thermodynamics and that you took in grade 10. So at this point, you should be looking at going to the textbook and working through the chapter prep and the unit preparation questions.